All right, so today we are going to talk about volumes of revolution by disks and washers. And so the first question is, what do we mean by a volume of a revolution, sometimes called solid of revolution? It's just formed by taking a region in two dimensions and rotating it about a given line. So I have some examples here. So in the green example, you can see first we start with this guy right here. And as indicated by this little arrow right there, we're going to rotate about the x-axis. And if we were to rotate it about the x-axis, it would create this figure here, kind of like a, a vase on its side. If we look at the pink example, now we're taking basically like a leaf, if you want to think of it like that. Again, rotating about a horizontal axis, this time not the x-axis, but still an axis of rotation. And it would create this figure. It's kind of hard to tell, but on the outside, it would make a bowl shape. But on the inside, we'd have kind of this funnel shape. It's kind of a cool figure. This guy, the orange one, if we take this right here and rotate it about a vertical line, we get this shape right here. And the outside, would make kind of this round shape. But on the inside, we'd have kind of a vase hidden on the inside. But again, we're going to look at how we find the volumes of these things. So that's what we mean by a volume of revolution. We're going to look at two methods, disks and washers. But before we talk about finding the volumes using disks and washers, let's make sure we're on the same page of what we mean by a disk and a washer, and also how we find the volume of them. So a disk, that's nothing special. It's really just a short cylinder. And so if you take a look, here it is. It's like a squashed cylinder. And the volume of a cylinder is pi r squared h, and that's the same thing for a disk. It's just h is really small. A washer is just a disk with a smaller disk removed. So this time we have two radii. So I'm using a capital R for the outer radius and a little r for the inner radius, that smaller disk that we're removing. So for the volume of a washer, it's just the volume of the big disk minus the smaller disk that made the hole. And in this case, since they both have a pi, we can factor that out. And they both have an h, and so I can factor that out as well. And so these are the key formulas to remember when you're doing volumes by disk and washers, because we're going to use these over and over and over again. Okay, I'm going to stop this video there. That's just kind of your introduction. And the next video, we'll talk about how we're going to create volumes using disks and washers.